Okay, the first step here is to choose our substitution. So we're going to let u equal the inside of the brackets 1 plus x squared. With experience, you get good at spotting what is a good substitution. And remember, you don't have to call it u, you can use any letter you like, so long as that letter has not been used in the question. But u is fairly standard. So now differentiate both sides with respect to x, and then rearrange. So treat this du by dx, treat it like it's a fraction. So multiplying both sides here by dx, and then dividing both sides by 2x gets us an expression for dx. That's going to form part of our substitution. So when we come to doing the substitution, that's what we're going to replace the dx with. Now in this one we have limits, and the dx tells me that the limits are x values. So those x values will need converting into u values. Let's do the upper limit. When x is 1, that means u is, well, since u is 1 plus the square of x, then it's going to be 1 plus the square of 1. So it becomes 2. And when x is 0, u is 1 plus the square of 0, so u becomes 1. So the limits become 2 and 1. Let's carry out the substitution now. So the upper limit became 2, and the lower limit became 1. And then let's do the substitution. In the denominator, we call the brackets u, so that'll be u cubed. I'm going to leave the x in the numerator alone for now, because I've noticed that when I replace dx with 2u over 2x, the x's are going to cancel each other. So let's tidy that up. We now have the integral from 1 to 2 of a half u to the power minus 3, and du tells me to integrate with respect to u, and it also tells me that these limits are u values as well. That's a fairly simple integral, and that's what you should expect after doing the substitution. What you're left with should be a fairly straightforward integral. So now we can integrate, so raising the power by 1, so raising the power of u by 1, and then dividing by the new power. We get minus a quarter u to the power minus 2. You can always do a quick check by differentiating that. So if we differentiate that, then we multiply by the power, and then take 1 away from the power. And yet that simplifies back to what I had before. So therefore I'm happy with my integration. So now we can put the limits into the integral. So putting the upper limit of 2 in, 2 to the power minus 2 is 1 over 2 squared, so that's a quarter. And now I'm going to put the lower limit in. 1 to the power anything is 1, so there we go. So we have minus a 16th plus a quarter, which is the same as 4/16. So the answer to this integral is 3 over 16. It was a definite integral, it had limits, therefore you'd expect the final answer to be just a number. Just be aware that there is an alternative method. Instead of changing the limits into u values, the alternative is to, once you have integrated, then put everything back in terms of x. So replace u with 1 plus x squared, put it back in terms of x, and then put the original x limits in. I don't do it that way because I think it takes a bit longer. It's quite quick and easy to change the limits. I would recommend doing it this way.